Welcome all. So in previous class we have discussed about identity, symmetry and operations. So today class we will discuss about axis of symmetries. So today class is axis of symmetry, because previous class we have discussed identity, symmetry. So today class we will discuss axis of symmetries. So if we say that axis of symmetries, then what is this? That when a molecule rotate along an imaginary lines, when a molecules rotate along an imaginary lines from its original orientations to equivalent orientations, equivalent or identical orientations. So this is called the axis of symmetry. The imaginary lines along which operations carried out or the imaginary lines with respect to which operations carried out is called proper axis of symmetry, and the orientations and that the movements which we do from original orientation to equivalent orientations, that the operations we called as, and the operations we did here, the operations which operations that we rotate the molecules from original orientation to equivalent orientations with respect to an imaginary lines, that operations is called axis of rotations. Okay, so and this axis of rotations, it is represented by, this is represented by Cn. Okay, where C represents the axis of symmetries and where N represents order of rotations. Okay, so if I say, let's if you take an examples of water, let's say H1 and H2. so here what we know, that 2 pi upon theta equal to n, this n, okay, where n is minimum angle of rotations. Okay, so if n is here, for this case how much we will rotate, 180 degrees. So if 2 pi means pi equal to 180 degree, and here this is 360, 180 into 2 is 360, and if we rotate by 1 80 degree, then n equal to 2. So here if we rotate this is axis, and if we rotate by 180 degree, then n is equal to 2. So here n is equal to 2. So here what? Cn, where n equal to 2, then this is become C2. So if I rotate this one by 180 degree, that is n equal to 2, so I can write it as C2. So if I rotate by C2, then what you will get here? So this will become here, and this will come. This is 2 and this is 1. Okay. So after rotations we should get equivalent orientation. So this is equivalent orientation. So this is a symmetry operations. Okay. So here we have to rotate by C2. So this is original. This is original orientations. This is equivalent orientations. Let's say if I talk about of it, then let's say this is a water molecules. Yes, this is a water molecules. This is a water molecules. If I rotate it by 180 degree, axis is passing from here to here. The axis is passing here. So if I rotate 180 degree, then how it will go like this? Yes. So in place of atoms, here atom is there. In place of atom, upper rotate also atom is present. So this is symmetric operation. Symmetric operation is valid only when if we rotate, after rotate, in place of atoms, atom should come. So here previously here red was there, here blue is there. Okay. So when I rotate here, again in place of atoms, atom has come, although atom has exchanged, but in place of atom, atom has come. So this is equivalent orientations. And if you notice it, let's say this is here and this is here past. Okay. So this pen tips is here, this is this pen tips, this is here. Okay. After rotates, these are going back sides. Okay. So after one rotations, this is going back. After again the rotation she will do, another rotation she will do, then only this is coming. So it means, so I will erase this. It means I can say that if water molecule is here, H1, H2, and if I this is the axis of symmetries, and if I do by 180 degree rotations, that is n equal to 2, so this is C2. So what happened? This will interchanging, so this will come H2, here will come H1. But what we see is that, see this is the atoms. So let's say here is red, here is blue. So after 180 degree rotations, what you are getting? This is coming. So here this pen cave, this was back sides. Okay. Let's say here you see these are front sides, these things, this. Okay. When I rotate 180 degree, then this they interchange with that, this going back sides, because front side this was there, after rotating this is going back side, means interchange also happened. At the same times this go back sides, this go back side, this go back sides. Okay. After that again when I rotate 180 degree rotation, that is C2, then what this again get in 180 degree rotation, again it will come H1, H2, again this will be in the front sides. Okay. Because if it is, these are fronts, whenever 180 degree back, again after that whenever I did another 180 degree, again this will going to be same place with this also again front. Okay. So this is again the front comes. So this is, if I say this is original, then this is equivalent, because equivalent means the operation is valid when in place of atoms, atom is coming or not. If atoms is coming, then that is a symmetric operations. If not coming, that is not a symmetric operation. But here In place of atoms, atom has coming, although atoms is going back sides and atoms is getting interchanged, but in space where the atom was present in previously, at the same space atom is coming, then that is a symmetric operation. So if not the equal to this, not same as this, then that is called equivalent orientations. But this is same as this, as it is the same to same. So in that case, this is called identical orientations. Okay. So if you see from here to here, how much rotations I did? This is one rotations I did, another rotations. So the number of operations needed to rotate these original molecules to get again the same original molecules, how many operations I need? This is 1 and 2. So from this to again to get identical operations, from original orientations to again to get the same original orientation, that is called identical orientations, the number of operations needed is 2. 1 times, this is 2 times. Okay. So here the number of operations, okay, the number of operations to get the identical elements or to get the identical molecules. Okay, so simply it will written like number of operations needed, means we have to understand that number of operations needed to get the identical operations is 2. Okay, so here which axis is present? C2 is present, so axis is present are C2 and no more other axis is not present, only C2 is present. Although planes are present, that we will discuss after if you discuss on plane. So now for this only you are discussing axis, so axis is only C2. Okay, let's take another examples. If I take the examples like C1 axis, where we have the C1 axis, the molecules, see these all the molecules are different, these 3 molecules are different, or I will draw. Here all the molecules are different, so if you rotate anywhere, then also we are not getting the same molecules, means after rotating the same molecules you will not get. Let's say the examples by top, FCl SO, the molecules is like F, S, Cl and O, this type of molecules. In these molecules that we will not get any excess of symmetries because all atoms are different. So this is the examples of C1. Okay, C1 means what we said, that we know that 2 pi upon theta equal to n. So where n equal to this 1 means n equal to 1, how we will get? This is 2 pi means 360 upon this has to be 360, then only we will get n equal to 1. It means here only you will get if you rotate by 360 degree only. So here only E1 only what, only E is present. So here for this C1 only E elements is present, where E element means where all the atoms are different, that is all are irregulars and they not have any chiral molecules like that molecules. So we will discuss. Okay, now for time being let's see it. So C1 is this type of molecules. Next type is C infinity. So axis of C infinity, the C infinity for this symmetries, which type of molecules it will like if we say the linear molecules. Linear molecules. How? Like say if I say CO. So in these molecules we know that 2 pi theta equal to n Cn for this n. So if 2 pi is 360 upon this is 0, then this is going to become infinity. Means n is infinity if n equal to infinity if theta is 0 degree. 0 degree. It means this type of molecules where we will find, like if it says, let's say this middle is our carbon molecules, and this is, let's say, oxygen. Okay, this is 2 are oxygens. Let's say this is middle one is carbon, and these 2 are oxygen molecules. So if we pass the axis of symmetries through like this axis of symmetry, if we are passing these molecules to this, if you pass one thread and if you rotate, then also we will see that nothing is happening, means the rotation is nearly 0 degree. Okay, so this type of the molecules where atoms lies nearly in the atoms lie in a line only. So on that case, if you rotate, then also the rotation is nearly 0 degree. If you 0 degree rotate, then we can rotate. So here the minimum angle of needed to rotation is 0 degree. Okay, so this type of linear molecules where the molecules lies only in a one line. Okay, so that whenever you pass the threads, then it will be completely cut the whole the molecules, because whole molecules are lie in the thread itself. So in this case, for rotating the theta threads, we need 0 degree. Okay, so the molecules needed is for this type of C infinity linear molecules. Okay, the linear molecules, it can be it may be I is present, I means center of inversion present or not, that's not a matter here. Only that has to be linear molecules, means the molecule lies in a one lines. Then on that case we will get C infinities. So examples, if you search like CO2, HCl, OCS, but that has to be lies in a one lines only. Okay, HBr, etc. Okay, all the linear molecules will fall in this C infinity, means all these molecules have this C infinity axis of symmetries. Okay, next, so if I discuss about of the lines of C2, we have discussed. C2 means for water molecules, like if we search, then C2 how will get 360 upon 180 degree, if we rotate, then n equal to 2. Okay, on that time here we will pass C2, then it will be get interchange, we will discuss. Okay, this is H1, this is H2, then this become H2, this become H1, and this is back side. And if you do again C1, C2, 2, 2. Okay, so this is C2. Okay, next examples, if you discuss, next type of examples, let's say C3b, so C3 type, C3 axis. Okay, next is C3. In these molecules, if you take the examples, let's say BF3. So in this boron atomic number is 5. So if you say that H2, 2H2, 2P1, so valence electron is 3. So what I do, boron valence electron 3. So here So to this 3 valence electron 1 F has joined. So here no lone pair is present. If no lone pair is present, then these molecules will be in the plane. Okay, these molecules will be in the planes. Let's see, it will be like that. Okay, fully in the plane. If you put in the boards, then it will be all will be in the plane. Okay, so here how will rotate? If I pass a threads to here, thread, then if I rotate the thread, then this will rotate like this. Okay, so here what I do, that C3, because if I pass C3, that is 360 upon 120, that is equal to 3. So I will pass C3, then this is like F1, this is F2, let's say this is F3, then this is rotate like this, here, here and here. So here it will go F1, here it will go F2, and here it will go F3. Again if we pass C3 to, then this will be, then this will come here, this will go here, this will go here, means here will be F1, this will F2, this will be F3. Again another rotations if you do, then what, this will go here, this will go here, means boron, means this here F3, the F1, this is F2. So you see that these molecules and these molecules are same, means this is identical. So how many operations are needed to get identical molecules? One operation is, this is 1, this is 2, another is 3. So total number of operations is equal to 3. Total number of operations means total number of operations required to get the identical orientation. So total number of operations equal to 3. Okay, so here which axis present is C3, and another axis also present. So let's say these molecules, yes, these molecules, this is the planar molecules, means these all molecules lies in here. Okay, so if I pass one axis cutting to this, so this C3 is passing, I am passing from here, passing, after that I am rotating. Now I am passing here for C3. For C2 what I do, I pass here, here thread will come here and come here. After that if I rotate the thread, then this will rotate like this. If I rotate the threads, then what happened, this thread will rotate, means thread is rotate like this, is getting constant because thread is coming this, okay, passing this and this, means wherever thread is going with molecules, that molecule will remain unchanged. So only this will rotate, so this will rotate like this. Okay, so it is, so this is constant, right? This is constant, means only these two will rotate because thread is coming like this. Let's say here, then for C3 I am passing here, and for C2 I am passing here. Okay, so thread is coming like this, and since thread is coming with these molecules, then this molecule will not rotate, only this will rotate, so this will get exchanged. Okay, so C2 is there. Similarly, if another case, if I pass the threads from here, then this will not change, these two will get exchanged. Okay, similarly other case, if I pass that one, so 3 C2 is present. And if you notice that, okay, first I will write, another is C2 is present, and how many C2? 3 C2. And if you notice that, what, that first case like this, so let's say for this case C3 is passing here like this, and C2 is here. So these and these are perpendicular, means C3 is here and C2 is here, means these are perpendicular. One is here, another is here, so these are perpendicular. So C3 perpendicular to 3C2, because 3C2 is there. Okay, and now one thing you have to note that here the principal axis, which is called principal axis, the order which is have highest number. Okay, the highest order is called the principal axis. So here two axes is present, and the highest order is, here order is 3, here order is 2. So which is highest? This is highest, so this will consider as principal axis. So if I write principal axis are what? Order of highest is called principal axis, and other than principal axis are called subsidiary axis. Subsidiary axis. This is other than principal axis. Okay, and one thing you have to note that whenever the principal axis is there, suppose principal axis is C3, then if the C2 is present, then the whatever the order, the same number of principal axis, same number of subsidiary axis is present. Let's say here C3 is the principal axis, here order is 3. So if C2 is present, then 3C2 is present, or if not present, then no C2. Okay, so whatever the order of the principal axis, same number of C2 is present. If C2 is present, other than not present, other than 0 C2. If present, then same number as the principal axis. Let's say if any principal axis is C4, then C2 will be present, then C2 will be per number of C2 will be present, means same as the order of the principal axis, that number of C2 will be present. Okay, so we will discuss whenever we are discussing about of that where C4 is exist, on the time we will discuss. Okay, so this should you have to note that. I will write principal axis. Here principal axis is Cn, so if n is the principal axis, then n number of C2 will be present, or 0 or no C2. Okay, if n is order of principal axis. Okay, this we have to remember. So we will take another examples. We have discussed about of that C3, we discuss about of C1, we have discussed about of C infinity, and we have discussed about of C2, and now we discuss about of C3. So let's discuss about of C4. And before discussing that, let's say if other molecules like ethylene, this type of molecules. Okay, so here that C2 is present like this also. This is C2. Here also you can get C2, and you have here also, if you pass, you get the C2. Okay, C2 means 180 degree rotations. If you rotate, then this also can exchange, C1, C2, C3, C4. This also can exchange, and if you rotate like this, then also it can exchange, and if you rotate like this, then also you can exchange. Okay, so how many C2s are? 3 C2 is present here, and here the principal axis is also C2. Principal axis is also C2. So here from if the order of any axis are same, then the axis which passes more number of atoms, that is called as the principal axis. So if the here this is also C2, this is also C2, this is also C2, this is also C2, but this C2 is passing with it is no atoms, it passed. With no atoms, it passing through bonds. This also passing through bonds, but this C2 is passing through 2 atoms. So this is principal axis. Okay, so if the orders are different, then the highest order is taken as the principal axis, and if the orders are same, then the axis is taken as principal axis which passes more number of atoms. This is also C2, this is also C2. Then for that case which pass more number of atoms, that is taken as the principal axis. Okay, so now next we will discuss about of that C4. Next example is we will discuss about of the C4 axis. For that, if he says that PtCl4, okay, PtCl4 2 minus. Okay, sorry, before discussing about of C4, let's discuss about of that. We have discussed now that if Cn, if n is maximum or principal axis, okay, then n number of C2 is present or no C2. Okay, so n number of C2 we discuss about of that BF3. Okay, here C3 axis is present and n number 3 C2 is present. Okay, BF3 molecules. Now we will discuss about of the NH3 molecules. In these molecules, if you say that atomic number of nitrogen is Z equal to 7, so 1s2, 2s2, 2p3, so valence electron is 5, so it will be nitrogens 1 2, this is 5 valence electrons. So